We will now be hearing from Judith Schwartz, who you may have heard the keynote last night, a global tour of Earth Repair. Judith is the author of Water in Plain Sight. She is also the author of the Reindeer Chronicles, and she will now be speaking on how water works, how much it moves across the landscape and through the atmosphere, and the understanding of which can help us address our many water challenges. And again, please post any questions that you have for Judith in our chat. Thank you, Judith. Welcome.
Thank you so much. And thank you, Susan and Peter. Peter, my talk will be kind of in dialogue with your talk. So yeah, we will see how that goes and what questions that sparks from others. All right, so I am doing that magical screen share. Let's see how this goes. I think we got it. Okay, can everybody see the screen? Yay. Okay, so the topic is water for a thirsty world. I have a garden at our home in Vermont, and this year I did a lot of watering. Through June, July, and most of August, I went out twice, in the morning and in the evening. It wasn't a big deal. I mean, I wasn't really going anywhere with the pandemic and all, and it certainly gave rhythm to my days, but it felt odd to be watering so much. And then I later learned that what we were dealing with, that certainly I was not alone, was a moderate drought in Vermont. This is crazy. So I don't remember, I picked this up off the web, but this is the state of Vermont, and like half of Vermont was in drought, and that's nuts. But here we are. Talk to anyone anywhere in the world, and you will likely hear that patterns of rainfall are not what they were, with heavier storms that increasingly cause flooding and longer stretches between rains. And water security is less dependable. Certainly, we were hearing about this, as both Susan and Peter were mentioning in terms of farming and the challenges of farming. I have a colleague in New Mexico who said that in the spring, authorities were confident that a strong snowpack would mean they'd be in good shape water-wise, but with high evaporation rates, they are back in drought. So yeah, so the point is that lots of challenges. I'm here to say that it doesn't need to be this way. Certainly, we live in a thirsty world, but we also live in a wet world. Achieving water sufficiency, having enough, but not a deluge, depends greatly on how we manage our landscapes. And our ability to do so will be greatly enhanced by understanding how water works, how it moves across our landscapes and through the atmosphere. And so that is what I will be focusing on. Alan Savory, known for developing the approach to grazing known as holistic management, likes to say, it's not how much rainfall you get, but how much effective rainfall you have. You see, you can get a huge amount of rain, and if most of it evaporates or runs off, you're no better off, and may have more problems like flooding, loss of topsoil, erosion gullies, and mudslides. As my colleague Precious Fury in Zimbabwe says, there are places where no matter how much rain you get, you end up back in drought mode. The water process here that's important, and again, what Peter was alluding to, is infiltration, the soaking of water into the ground. This has much to do with the quality of the soil, since carbon in the soil, a significant part of organic matter, acts as a water-absorbing sponge. Another key factor is soil cover, which deters both runoff and evaporation. Okay, So we're gonna stay in Zimbabwe for a bit. By the way, this picture of Alan was taken by my husband in Zimbabwe because we had the incredible opportunity to spend about 8 days with Alan and his wife at the Africa Center for Holistic Management, which was wonderful because it's one thing to hear stories about how a place has transformed, and another whole dimension to actually see the land. So in Zimbabwe at the Africa Center, enhanced infiltration, which was accomplished through holistic planned grazing, which enhanced the carbon in the soil in multiple ways by the hoof action of the animals pressing down the decaying plant matter so that it is incorporated into the soil, and through the waste of the animals, which adds moisture and fertility, and all the other factors of the animals, when they move, they are pressing in seeds, that a diversity of plants gets a chance to germinate. And anyway, all of those processes over time, over 10, 15 years, greatly enhance the ability of this land to hold water. What this has meant is that the Dimbengombe River now flows a full kilometer further into the catchment than it has in recent memory, in anyone's living memory, and that it now flows throughout the year. What is extraordinary is that the region has been suffering huge droughts, and also, the mirror twin floods, but the land at the Africa Center has maintained its green. It has been thriving. So here, just another aspect of what happens on this river is that the holistic planned grazing meant that the banks were stabilized so that you didn't get the soil running down into the river, which causing siltation and other problems. But because if the animals had been unmanaged, they would just be hanging out by the water, and then you would get they would be devegetating the banks, and then you'd get all that erosion and flow. But because the animals were there only specific periods of time and then moved elsewhere, that didn't happen. And the river now has come back, along with a huge amount of wildlife that they had not seen there for decades. And this is what it means in human terms. When I was in Zimbabwe, I had the chance to meet people in villages who were working with the Africa Center for Holistic Management. Animal impact, again, managed animal impact on their croplands meant more soil organic matter, which meant better water infiltration. For the people in Sianyanga, Zimbabwe, way off a dirt road near the Wangi National Park, that meant being able to grow food for 7 months of the year rather than 2 or 2.5 months of the year around the rainy season. And this meant the difference between food self-sufficiency and dependence on international food aid. And talking with these people, the sense of pride that they have, that they can now support themselves rather than have to go and line up for a handout, meant the world. Now we are shifting to another water process, transpiration, which again, Peter had alluded to. I interviewed for my book, Water in Plain Sight, Antonio Nobre, the author of a report called The Future Climate of Amazonia. The Amazon rainforest has about 4 billion trees. Together, these trees act like geysers and spout a river of vapor into the air, an aerial river through which flows 5 times as much water, Actually, I'm not sure. I have to go check that again. At least as much water as the Amazon River itself. This flying river is the result of transpiration, the upward movement of water through plants. You can think of it as the plant sweating. The stomata on the leaves, or if we're talking about grass, the blades, open to retain or release moisture to cool the plant itself and the nearby vicinity of the soil. It's worth noting that this is a cooling mechanism, transforming solar heat into latent heat suspended in vapor, as opposed to sensible heat, or heat you can feel, like that hot sidewalk that Peter referred to. According to Czech botanist Jan Pokorny, the transpiration activity of one tree on one sunny day represents 3 times the cooling capacity of an air conditioner system in a 5-star hotel. The cooling factor is important, but transportation also drives the movement of water. There's an excellent paper by biologist Douglas Scheel called How Plants Water Our Planet. It begins, most life on land depends on water from rain, but much of the rain on land may also depend on life. He looks into recent research showing that vegetation has an influence on rain and rainfall patterns. Most significant are trees, as we've seen, they are champions at transpiration, but also grasses. Transpiration from plants accounts for 80 to 90% of the atmospheric moisture over land, and this is important for rainfall. According to the nonprofit We Forest, about 40% of rainfall over land is recycled from evapotranspiration from landscape surfaces. That means from the soil and from the plants. Ecologists are starting to talk about using the term precipitation shed to describe the source area of land and water that generates a region's rainfall. Finally, we get condensation, the process of water vapor turning back to liquid. In order to condense, water needs something to condense around, precipitation nuclei. There's a lot of new research about the microbiology of rain and how bacteria and various volatile organic compounds, Antonio Nobre calls this fairy dust, from plants, how they play a role in creating rainfall. Condensation is also a source of water. I write about a couple in far West Texas who designed their rain barn to collect condensation. They didn't realize how much water they were capturing until the winter morning, 4 months since the last rain, when the water tank overflowed. And here we are visiting Catherine and Marcus Ottmers, and Marcus is showing us the water tank that overflowed that January day. Australian farmer Chris Hengler, who applies holistic management on a land area the size of the 5 boroughs of New York City, says that he pays as much attention to dew as to other sources of water. He says there are all those additional microorganisms that can keep active throughout extended periods well after the rainy season, as long as they get a watering each night. In a living system, moisture generates more moisture, he says, of which dew is one manifestation. These processes have real-world impacts on water availability, the state of our landscapes, and for climate. And how we manage our land and our built environments determine our ability to make the best use of the water we receive. I now want to introduce you to Professor Mian Mian, an atmospheric physicist and meteorologist who for a long time managed and directed the Center for the Center for the Environment of the Mediterranean in Valencia, Spain. He's done extraordinary work in his career, but what is most important to him right now, what he's been focused on for a while, is his research on the loss of the summer rains in the Western Mediterranean. From the mid-20th century, this region was rapidly developed with forests cut for roads, soils covered by development for hotels and residences, and wetlands drained for farming. So this completely changed the water dynamics in the area. Fewer plants meant less transpiration, and the daily rains stopped. Now, Mian has done a lot of research, and what he found is that the moisture from the Mediterranean Sea was never enough to make a rain, and that the water picked up over the vegetated areas created a situation where there was a high enough moisture concentration to get precipitation. So that's really, really powerful, you know, because when we often hear about rainfall and we hear about climate change having an impact on the amount of rain that we get, it's really important to understand the agency that we have in terms of how we manage our land. So Mian is very focused on this in part because now that we understand this, he believes that revegetating, strategically revegetating the region will reinstate the rainfall. Although, and this of course is a big caveat, it may be tens of kilometers away. And so this, he says, is one of the challenges of the land, rain, climate dynamic, is that you can't just say, okay, we're going to plant trees that replant the trees that had been here, you know, decades ago or 100 years ago, and then we're going to get the rainfall right where we want it. We may get rainfall elsewhere. So anyway, that's important, but I just think that's really, really powerful to understand where we do have agency. So that's an introduction to water processes, and I want to close with a quote that I like very much. There's an Australian farmer, horse breeder, kind of cranky guy and author named Peter Andrews. And there are a lot of people in Australia who have been doing deep thinking about water climate dynamics because they have been seeing impacts ahead of most of us who are finally getting the picture now. So Peter Andrews says, plants manage water, and in managing water, they are managing heat. So I love that in part because it's kind of like a haiku, but also it is another way of articulating what Peter Bain was saying about, for climate, we need to regreen. We need to reinstate the climate regulation capacity of the plants on our earth. And as Peter Andrews says, in terms of this temperature regulation capacity of plants, we have devegetated about 1/4 of our planet. So this in itself presents to us our task. And it is a task that we can embrace and move forward on through all of the ways that Susan and Peter and all of our other speakers have been highlighting throughout the conference. So thank you.
Thank you so much, Judith. This was such an inspirational talk about, we are beings of water. We are, it is no different, the water that is on the planet and the water within ourselves, and we can nourish these connections. And I loved how you talked about plants manage water, and how we need to regreen the planet. It was beautifully spoken. We now have some time to answer some questions. Please put your questions into the chat. I know right in the middle during your discussion, the major news outlets just announced the winner of the presidential election.
Oh, okay.
Right. Yeah, that was shocking that Biden has now won the presidential election. And you actually ended your discussion talking about how we need to regreen, we need to reinstate climate regulations in our capacity. So maybe you could talk about what we can do for the future with our planetary vision for regulation.
Yeah, what I will say is that that is being articulated in many places simultaneously. As we are speaking, there are conversations happening with many groups that I know of, and one that I mentioned yesterday evening is that the UN has declared the next decade the UN decade on ecosystem restoration. So this can be a rallying point. And I'm certainly in conversation with people at the UN on how to ensure that the message gets out, and different ways to communicate and engage other people. So, you mentioned the presidential election. Well, I know of a number of climate activists who have been speaking to Joe Biden and are saying that his understanding of climate and what needs to be done is deeper than may be evident from the discourse that we've been having. I'm almost smiling. Yes. So I know people. I'm reassured that I know people who are in conversation with him. So
that is good and hopeful news, that conversation is happening, and it's a welcome conversation. Michael in the chat says, so many communities have major issues with stormwater management. What solutions have you seen that communities and property owners might adopt?
yeah. So, this puts me in the zone of some water, the new water paradigm. There's a group of Eastern European scientists and thinkers, one of whom I mentioned, Jan Pokorny, who, I'm trying to think how long ago this was, but many years ago, 2012, 13 or something, created a brief book called The New Water Paradigm, Water for the Restoration of the Climate. And what they pointed out is that when we created our cities, I mean, this is, through time, that the idea was that water was a nuisance and we need to get rid of water as soon as possible, rather than holding water on the ground. So we're now getting situations with heavier rains that many communities have a situation where the stormwater systems were not built to deal with what we have. We also have more paved over surfaces, which by definition do not hold on to water. So what I would say is that communities would be best served to think about ways that they can hold water on the land. So improving soils, and medians on the roads can be worked with so that those can be, that the soil can hold water, different types of earthworks, looking where the water is a problem and steer water towards where you want water to go. I'm sure Peter knows, as a permaculture teacher, knows a lot more about this than I do, but I'll also just add that an acknowledgement that the more sealed surfaces we have, the more that puts pressure on the stormwater management system, that some communities are actually like taxing people according to how much sealed surface that they have, how much roof or sidewalk. Yes, it looks like Peter would like to add something.
Well, one of the things that we've seen starting in Central Europe but spreading to other parts of the world in the United States is the expansion of green roofs in urban areas, because they retain rainfall for 24 to 48 hours, substantially much of it, and release it slowly in the way that a farm field or even better, a forest would do. And so that's now becoming mandated in some building codes and so on. Detention basins where water can be held and released slowly and allowed to sink in. Rain gardens everywhere. In extreme situations, like Brad Lancaster has done in Tucson, curb cuts where water sluicing down along the gutter gets diverted into his forest garden plantings. He just reaches out there and grabs it and puts it down into the soil, to make the most out of 12 inches of rain a year that they get there. There are many solutions. I mean, we need de-paving, we need less paving, we need permeable paving, we need tree planting that can open up soil pathways to get water into soil, and all the other things I mentioned. That's in urban areas especially, but our urbanization in this country now extends in a network across the country, because every interstate highway is essentially an urban zone with high levels of paving and vehicle activity and heat and all of this. We've just, thrown this whole urban lattice over the country. So we need to think, outside of old-fashioned boxes. Like, we've got these kinds of problems everywhere, even in rural areas. And then we ought to be introducing more and more agriculture into our cities in green spaces. In some places, we need more concentrated development. In other places, we need less. There's places where houses shouldn't be built or should be taken down. Richard Register wrote, writing about eco-cities, would say, we build up near the transit zones and we build down in the exurban areas where we're just sprawling. You keep the number of people the same, but you redistribute the buildings and the infrastructure. So you have absorption zones, and you use those green fingers that reach into the city and surround the city as the lungs and the food growing zones and the absorption zones and the wildlife zones, so that we get a more balanced ecosystem for everyone.
Yeah, well said. Thank you.
Yes, I'm wondering if there are other of our panelists who might want to weigh in on this really rich topic, and ask questions as well.
Yeah, well, I did want to mention that Doug Tallamy's talk yesterday, he spoke about all the land that we don't necessarily think of as ecosystem, like, like along the roads, et cetera, et cetera. So I think that even just opening people's mind up to the idea that ecosystems are everywhere is really an important piece of our work. And then on a farming level, not that I have a lot of answers, but I know that that's part of the thinking about how you transition larger farmers to small farms. Part of that is taking areas that are now too wet for folks to plow and thinking about, could you help them transition small parts of their farms to different kinds of whether it's permaculture or perennials or just different kinds of planting. So I do think, I think in general, if, as I mentioned, COVID being an opening, I also think water is an opening, because if farmers can't plant their fields, then they're not going to make any money. So just people who kind of come up with ideas or are there to model ideas of what can be done with wet ground are going to be increasingly important.
I think what we don't know, because it's historically behind us, we weren't here to see it, is that, there were 200,000 square miles of eastern North America under swamps and beaver ponds. So the landscape really wants to be wetter than it has been. We've dried it out to grow row crops, but maybe the future of row crops is they have to live with interspersed swamps and ponds and aquaculture systems and strip forests, and it becomes a more complex, nuanced, but also much more stable agriculture than the one we have now, which is boom and bust, heat and drought, flood and famine and fire and all of those awful things.
Mhm. Yeah, definitely agreeing on the beavers. And I know that there's a lot of work being done in the Northwest and in California on bringing back the beaver, and certainly in Europe and the UK as well. And one thing that I found in my doing my research for the book on water was the connection between water and biodiversity, and while it certainly makes sense that a functioning water cycle will benefit biodiversity, what I hadn't expected to find is that biodiversity enhances the function of the water cycle.
Yeah.
So you want to slow the water. You don't want water running off fast. You want to slow down the water, and different species from the beaver to prairie dogs to earthworms and dung beetles and everything that every critter that crawls are creating, and ants are creating paths for water to meander into the landscape.
Hi, I'm sorry I joined you late. Greg here. I wonder if I could ask Peter a question, since we didn't get a
Sure.
chance. And it just has to do with you mentioned that we may have in fact thwarted or the impending ice age that we were scheduled to, right? It was scheduled to arrive.
Yeah.
Question to you is, since that you mentioned that there are certainly more than 4, there may have been up to 20 or 50 glacial periods. Is there a function? What's there has to be an ecological function. There's a reason why we've had these glaciations. I mean, Louis Agassiz called them God's great plows. And so if we have in fact done that, I mean, my question is, have we somehow interrupted an important sort of cycle? And do we know what that is? I'm thinking more about the crushed rock, to sort of things that
Yes,
have happened.
absolutely. Well, you're right. That's maybe the first place to go with that question and an answer, is that glaciation refertilized large areas on the edge of the ice slopes. It ground up minerals and boulders and redistributed minerals over the surface of millions of square miles. And that's one of the reasons our farm belt has been so productive for as long as it has, despite poor agricultural practices. The soils are deep. I grew up in Champaign County, Illinois, and the backyard where I lived, you could dig down 6 feet. It was all black dirt. It had grown under prairie soils, and that mineral had been brought down from Canada. So there's that, and people who are considering how we might deal with those long-term cycles are point to remineralization, which is what the glaciers did, as something that we can do at a micro scale. That is, we can do it on the farm scale or in gardens and so forth, using available resources of local minerals, and also farming differently, so that nature is doing a lot of remineralization. Every time you bring in birds, they're bringing in minerals and depositing them. A bird takes off, it leaves a packet of goodness behind it, and that enriches the soil. We have to think about all of those cycles, but I think the glaciers serve that role. I mean, I don't ascribe some sort of grand design, like, oh, well, let's have glaciation because the earth needs it now. It happened a bit accidentally. As I say, the tectonic movement of plates brought about different oceanic circulation that sort of triggered this cycle that interacts with the sun. You know, it's like, wow, look at this system. But it's highly sensitive to subtle changes in solar radiation, you know, the angle of incidence, and, you know, it takes a while for these things, long periods of time for them to switch over, and then they can switch extremely fast. So, you know, we had an incident in the early interglacial period called the Little Dryas, where it's believed that a big glacial lake in Canada burst out of its bounds and flushed into the North Atlantic and freshened the seawater and broke the thermohaline circulation between equator and pole. And we plunged into 1,500 years of ice age after warming fully. And then in 10 years that ended, and it went back to warming. So the system is incredibly dramatic, and we're in the epicenter of it here. That's another thing to remember, is North America is really the flywheel of the planetary glacial climate system. So we have an opportunity to be a big influence if we understand the system and work with it to achieve stability. It's a great question, Greg.
Yeah, I know I want to add from an Indigenous perspective, when we're talking about the types of trees and other plantings, there's the story of what happened in kind of the southern part of the United States with the incoming peach trees, and how the shade that they created on those lands destroyed a lot of the different roots that were used for the foods and for some of the food trade routes that were happening all over the United States. So looking at what's happening for connecting Indigenous science forward, a lot of different Indigenous people are looking to give land trust to Indigenous farmers so that they can incorporate some of those tools back into how we feed our own communities, and then reattach the food trade routes that were here in the United States originally. And that is work that is just now being done in part through some legislation that's being put forward. And we need, as Indigenous communities, we need allies and accomplices in that work. And I'm curious about how water can really play into that as we are regreening, and how are we collecting water, and what are some of the technologies that we can have access to help collect water and help be a part of that regreening.
Well, the technologies are many. They're worldwide. They've been practiced by Indigenous peoples on every continent. There are some phenomenal stuff being done. Gary Nabhan, the ethnobotanist and professor at Northern Arizona State University, has written a wonderful book called Growing Food in a Hotter, Drier Climate. And he's gathered all kinds of techniques from the Middle East, from the Southwest, from other arid regions that are increasingly relevant for all of us as we face climatic swings and pressures and heat, different farming practices, different ways of capturing ephemeral runoff, of incorporating plant residues, of doing all kinds of things that most farmers haven't had to think about. Small check dams, gabions, which are rock-filled baskets woven together in streams. The ordinary practices that don't seem very dramatic, laying things across contour, on the contour across the downhill flow to intercept the movement of soil particles and water and organic matter. I have a whole set of images from this group that's around Jan Pokorny and Mikhail Kravchuk that I was going to share, but didn't have time. So maybe in the afternoon session, I can show a few of those. Some really beautiful artistic work that's done, water bars on roads, woven brush fences across the bottom of fields, permeable dams made of wood and stone, there's no end to what the imagination can produce, and artistry in our land care. Living sculpture, willow rods driven in and woven and pleached together to make permeable barriers. You sort of have to work with what you have, because you can't import lots of materials. This has to be done everywhere on a vast scale. I was working a few years ago up in the mountains in Colorado on the western slope, and we wanted to slow down water coming down the drainage. I mean, it doesn't rain a lot there, but sometimes they get a little bit flooding and snow melt. And what we had laying around were big round cobblestones and old car parts, and bundles of thistle that we cut and bound together and laid, crossways on the slope. There's literally a million ways that we can hold water back. But the great advantage is water always goes downhill. And all you have to do to slow it down and get it to sink in is to spread it out and be perpendicular to that flow.
Well, that helps us transition into what we have next. I just want to take a moment here to thank Judith for her wisdom and all of the beautiful connections that you helped us. Every time you speak, I feel like I'm part of the entire globe. It is, and I feel like these connections to communities that I maybe have never visited in my life, but you've somehow given me that opportunity. So now, thank you so much, Judith.